Yeah, let me start off then. Thank you people for joining our already fourth Cup of Tech presented by Nobelproc. My name is Roy de Bocht. I'm the representative of Nobelproc in the Netherlands. Thank you for joining. A couple of administrative details up front. Your lines have been muted, but we will open up the session for a Q&A later on. If you have a question to ask, please feel free to raise your hand, and during the Q&A, we will open up the mics so you can put your question to Priyanka. We will be recording this session as well. With participating, you will give consent to have this used for marketing purposes or advertising. Next, I'd like to introduce our presenter for today. We are very proud and happy to have Priyanka Sharma joining us today to give a presentation on AI and the effect that COVID-19 has on the usage of artificial intelligence and machine learning. Priyanka is a academic researcher and consultant on deep learning and data analysis. He has a track record of 20 years of professional experience in both the industry and on university. She's also internationally known because of her academic work, and she's actually guiding 6 PhD students to become a PhD. So with much pleasure, I pass on the microphone to Dr. Priyanka Sharma, who's going to teach us on what machine learning has done for us in these times of Corona. Please go ahead, Priyanka.
Thank you, Mr. Rose, and thank you, Nobelproc, for having me over here. It's my pleasure to speak on COVID-19 as a catalyst for human and AI interaction, and I would try my best to justify this 1-hour session that we all are together. So just to start with the brief of this topic, I would like to mention that we all know COVID-19, how it has transformed our lives and has affected every domain of our existence. However, at the same time, this pandemic is also leading the world towards a single point agenda, right? And that relates to surviving ourselves against this situation. Every domain defining the new norm, and science and technology as a whole is towards building a close collaboration for this change. Therefore, the pandemic has not slowed innovation, according to me. It is rather amplifying it to historic levels and has become a catalyst of change. And this subsequently has exponentially increased the need for human and AI interaction. Therefore, we no longer have geographical boundaries, and hence we need to collaborate at a larger scale with this point of agenda that has integrated the world in terms of realization of newer technologies to bringing back the world before the coronavirus pandemic hit us all. So the present webinar basically focuses on covering interesting insights on various application domains that has enormously developed for past few months to resist the downside of the effects of this pandemic. Which includes, development of sterilizing and cleaning robots, to drug discovery and genome sequencing, to the use of AI in public health surveillance, to GPS-based contact tracing, to what else? The COVID-19 diagnosis and radiology, to antibody testing, and many others, right? And the major contributor that is driving all these applications, which I just mentioned, is AI and data science. So building intelligence into actuators backed by this, this disruptive science and engineering practices and applications is what the year 2020 is to be all about. So So that was the base of the presentation and an abstract of what we are going to talk for rest of the time that we are together. So this image that you see was published in December 2019 by Forbes, right? Where for the Forbes prediction for 2020 was basically published that this is going to be a year of AI and ML, and the COVID-19 crisis has actually further accelerated this man and machine interaction. So in fact, to start with, my take uh, on how AI is transforming this fight against the pandemic, I would also like to share a personal experience of last 6 months, which has surely been very eventful for all of us, with many soul searching experiences, spiritual readings, self upgradation, whatnot, holistic living efforts, and with ample amount of thoughts that make you feel low. I found a great amount of solace in reading some of the books that ignites our minds with very realization of strength of sapiens, right? We are sapiens, and strength of sapiens that has always increased our competency and community behavior in times of crisis. So this book, Sapiens, A History of Mankind by Yuval Noah Harari, is surely a must read for all of us in terms of, awakening your souls with our inner strength for innovation and skill development to accommodate ourselves and basically build upon the concept of survival of the fittest, right? So another interesting reading that's worth quoting over here is a book by Alec Ross, which I had read some time back, which was on industries of the future, right? And now, I mean, the recent analogy says that why the industries of the future matter now. And if you happen to read this book, right from the third chapter of the book is dedicated to robotic revolution, right, which is going to drive the world in one or the other way. So basically, in summary, we should explore variety of reasons to feel motivated for more and more learning, and also possibilities of self growth, right? So that's what I wanted to start with. So just 2-3 slides I wanted to discuss about these three words that coins the need for the type of application innovation that we have been talking of, and that's AI, machine learning, and deep learning. So as you can see on the time scale, AI is not new, right? It started off in 1950s, in fact a little before that as well. And you can see then we had machine learning, which is like a group of intelligent algorithms, which was meant for developing learning capabilities in machine. And then from 2012 onwards, the term deep learning became so popular. In fact, the first deep learning algorithm was written in year 1998, right? That was the LANET algorithm, LANET 5 algorithm, but the acceptance of deep learning in terms of developing algorithms which has got self-learning behavior to so much extent that in many cases it has surpassed human intelligence, right? And that basically is the need of acceptance of deep learning based evolution in automation systems. Whether you talk about the radiologist acceptance of deep learning based diagnosis from CT scans, X-ray scans, MRI scans, or you talk about any other applications. People of bioinformatics domain using AI for automation of drug discovery, it's just phenomenal. Deep learning has been accepted in varied domains of science and engineering. So basically, the outline of this presentation is to talk about the AI factor in terms of its adaptive nature, self-learning, and basically combating the change. So I'm going to basically talk about various applications, because we have a mixed group of people in the audience today. So I'm going to take examples, variety of examples, and basically discuss that how AI has been used for prediction and trend analysis related to COVID-19. In fact, all the case studies which I'm going to take are mostly COVID related, right? Because that's discussion today. So I'll be talking about AI for prediction and trend analysis, using AI for testing of COVID-19 infection in people. Then AI for tracking and prevention, which is like the development of surveillance tools and many things like that. And then AI for support and treatment. So these are the 4 categories of discussions and case studies that we're going to talk about. Of course, this is one of my favorite slide, because this Big Bang in machine learning is basically brought by 3 major components, and that is the deep neural network, which is the algorithmic development in the backend. Sometimes we directly use them, and sometimes we indirectly use them in terms of APIs, right? And then the availability of high computational devices in terms of GPUs, that's graphics processing unit, which is the base for developing these specialized applications. And then, of course, large amount of data, which we need, because these systems, they build on experience. So the better the quality of data you can get, better is the quality of the outcome of the applications that you design, right? So that's why we typically call this as the evolution in these 3 domains is what has led to this Big Bang in machine learning. And of course, I'm not going to discuss about these algorithms, but for the audience, just to relate with the variety of applications where machine learning is used, and sometimes we may know about it, and sometimes we are using it and we don't know about it, right? But in the background, ML is definitely used in one or the other way. So all these smaller font items which you see, they are applications where some variety of machine learning algorithm is used. So whether you talk about big data visualization, or targeted marketing, or real-time decision taking, robotic navigation, population growth prediction, estimating life expectancy, advertising, and many other things that you see over here, they are using machine learning in one or the other way. Right. So typically when we try to solve an AI or deep learning based task, our task is categorized into these 5 categories, which is either trying to detect something, right? And then I have shared some examples to relate to these terminologies, right? So we have detection algorithms, we have algorithms, which is like identifying something, and then we have segmentation algorithms. So if you see on the right hand side, there are as against to each one of them, there are examples in terms of cancer detection. Okay, and so segmentation, tumor size, we all can relate to cancer detection, right? So tumor size identification, shape analysis is what is segmentation all about. Prediction, like survivability prediction. So this may just help in identifying how much chemo dose can be administered to a patient, and basically, taking decisions based on whether there are chances of survivability of the patient or not. So lots of diagnostics with respect to this. And then the recommendation system, which is very popular, Facebook recommendation and Flipkart recommendation. Recommendation is everywhere these days, right? It sells on most of these marketing systems that you're using. So therapy recommendation. These are the 5 categories of AI and DL task which people try to solve in one or the other way. And in majority of these tasks, your input is either a text data, it's an image, it's a video, and it's audio, right? And these 4 types of data types can build a variety of applications that you come across in your AI-based applications. So how is AI helping fight COVID-19? So it's basically helping in terms of prediction of the spread rate and distribution, helping in testing of the COVID-19 patients, helping for tracking and prevention, helping for support and treatment. And you can just see for prediction, it's like geographical prediction, prediction, the spread distribution, how it's spreading in a particular area, country-wise analysis, and then we have so many popular dashboards which is giving us this kind of information these days, right? So they are all a group of AI algorithm working towards prediction and time series data analysis and things like that. And then we have X-ray and CT scan imaging, and in fact robots being used for testing as well, like symptom recognition of coughing, right? And based on the analysis of how the aerosol particle travels when somebody is coughing, basically trying to identify various other things, and for tracking and prevention, we have people working towards public surveillance. We have discussions for each one of them. So right now, we can just see this in summary. Support and treatment, we have robotic automation for healthcare and monitoring, sanitization robots, drug discovery, and the entire world is struggling to identify the right vaccine for COVID-19. And the problem is primarily because the virus has multiple strands and it keeps mutating. So you make a vaccine, and then we all are exposed to the challenge of drug discovery, and people are using AI in one or the other way to automate the studies related to this process as well. So I'll just talk about some applications which were used for prediction of the spread rate and distribution. And here I'm just sharing this 2-3 screenshots. The first one which you see was published on 31st December 2019, much before we all even heard of it properly, right? And it was WHO who published that coronavirus, about the coronavirus outbreak, and just before that, if you see the screen on the left hand side, that it was a AI based startup called Blue Dot. It's a Canadian startup called Blue Dot, and they basically picked up some unusual pneumonia or unusual pattern over the Wuhan market in China, right? And you'll be surprised to know that all these this prediction that Blue Dot basically made was based on the GPS locations of people, the travel history, the population data, right? And lots of textual exchange of information, like the chats, or in fact reading elements from social media posts, right? So if you just get to read how Blue Dot basically operated in identifying something for the first time, right? And it was a little after midnight of December 30 that they published that there are some unusual pneumonia cases happening around in market in Wuhan, and this was later on picked the very next day by WHO, and this was also published on 9 January by Centers of Disease Control and Prevention. And what was possible, of course, we all didn't have trust in this particular news outbreak at that time, but this was basically a model training based on an AI task, right, using this variety of data which I just shared with you. This is a snapshot of a COVID-19 dashboard, which is developed by Johns Hopkins University. And if you get to see this, maybe some of you might have already seen, the data keeps changing every day, right? And every few minutes, you see the data keeps changing, and they give you the latest information related to cases registered country-wise, location-wise, right? To check the area where there is a more infection, you know, and how, if at all it is going from one location to another location, what is the pattern in which the disease is moving. And these are all AI based you know, model training that goes behind developing applications like this. These are also, you know, snapshots of some of the applications where, you know, this snapshot which you see is a look at how social distancing measures may have influenced trends in COVID-19 cases and deaths. This is an interesting graph which you know, which talks about trends in confirmed cases all over the 50 states of United States. And I've just zoomed one of them for the New York City, right? It was too much in news, and you know that how the pandemic was like devastating in the month of April, May, you know, and then slowly it receded off. So the trend, and all these graphs that you see is trend. So trend analysis. This trend analysis is also something which is done by processing time series data for data with the deep learning based algorithms. These are daily confirmed new cases, 5-day moving average for different countries. So, I mean, for India, you see we know that the numbers are rising, right? The green one is for India, and likewise for other countries. All these, and then suppose we are here, so what next? What is the trend, whether it's going to fall or it's also going to rise? So that kind of future prediction is what is done based on AI based algorithms. So the past is something that leads you to the future, and the accuracy with which you can predict the future is something what these algorithms are supposed to be good at, and they are actually good at, right? So that was about the way AI is being used for prediction. And now I'll just talk of a few examples to discuss how AI can be, you know, used for COVID-19 testing. So these 4 images that you see is the first one which you see is a chest CT scan, right? And then on top of this, a deep learning algorithm has been, which is a ML. We already discussed what is deep learning, right? It's a self-learning algorithm. So deep learning algorithm has been run over, has been trained on this as an input data, right? And then it's able to generate a lung segmentation, and from the lung segmentation, people are able to write algorithms to generate abnormality segmentation. And the red ones which you see are the abnormalities identified. And accordingly, there is a grading here which says that lobe-wise severity. So the darker ones, darker reddish ones are like more severe problems. So severity of the infection of a particular patient is can be diagnosed or identified with the help of deep learning algorithms. algorithm where CT scan is the input, right? And you'll ask, what's the advantage of doing this? Because the doctor anyway gets to know the severity, right? So the advantage could be in terms of developing, let's say a particular hospital has got 100 or let's say 50 ventilators, right? Or maybe lesser than that. So if there is a surge of patient, basically a model that or a ML based model that helps you identify what's the severity in the infection, chest infection of the patient, based on which you can prioritize that. Okay, given the limited number of resources, how should I prioritize the allocation of ventilator facility? This is in fact, NVIDIA is working on a project like this through federated learning approach, right? And federated learning approach is a machine learning based training where we are collaborating with a number of countries, right? And they have a model trained for patients of US, they have a model trained for patients of UK, for India, likewise for other countries. And then on top of that, they have a more mature model training. And the intention is what? Intention is basically to develop a kind of grading facility to identify whether how needy is a patient to get a ventilator facility, right? So in times of crisis, likewise, whatever I've shown here, likewise, this is just a deep learning model, which is typically used for solving problems like this, right? So you take the data, you apply some kind of data pre-processing, and then you give that to your deep learning model, then you train and you test them. This we are not discussing, but typically this is the flow, right? And the system basically builds on the data availability. So when I gave you example of the federated learning approach, which is used by NVIDIA, the reason is that you don't have a huge global data set of COVID-19 CT scans, right? And this is something which is every day you have data of, let's say, thousands of patients all over the world. So instead of working from a centralized perspective of getting all the data onto one place, they have devised a distributed machine training environment where people are able to sit at different places, and then they are able to contribute to this cause, right? So that's like working on a research problem without any geographical boundaries, right? And this kind of model training experiences are being developed by prominent companies to basically come up with something substantial to fight against the present situation. And similar in lines to this that I've shown you, people also work with X-ray scans, right? In fact, this image that you see, I don't know if I can play this. There's some issue with playing the model. So basically, with two of my students, I have also developed basically a deep learning model where we are able to give a chest X-ray as an input, and the model is able to predict the severity of the infection. And for this particular research, we have collaborated with a government hospital in my city, and they have agreed to give us the required amount of data based on which we are training our model. And we are also working on providing this as a facility to people staying in remote areas, right? So because in remote areas it's possible that they have an X-ray machine, but they don't have expert who will look into the chest X-ray and tell them that, okay, this is the diagnosis. Okay, so with two of my people, I'm also working on a research like that. Then comes AI in tracking for prevention, right? So here again, this is let me see if I can play this.
Perhaps you need to share another screen, Priyanka.
Yeah, I'll share another screen. Just a second.
Meanwhile, if you do have a question, please raise your hand and I can open up the
if you have a
microphone for a
question, you
question.
can raise your hands. So this video that I'm showing is from an application which is working on identifying social distancing. You can see that the deep learning model is trained to identify people, right? And as the moment they are closer, like these two people are closer, you will get the red box. And as long as they are at a safe distance, the box is green. So if you have too many red boxes appearing in a particular area, the camera, so it's like you can have a camera where this particular model is fed, right? And the moment you have too many red boxes, or I mean it depends what kind of a security measure you want to work on, the system will work towards flagging that the social distancing is being violated, and then accordingly it can be it can be informed to whoever is trying to control that particular situation. Let me just share back my original screen. So I have actually worked on an application to develop the social distancing from video analytics perspective. So it's a simple application where you capture the video from the live camera, right? And then there is a ML module that takes that particular data as an input, and it identifies if the social distancing is being violated, and accordingly, it generates the required comment or required output or flagging message. These applications that you see, is the first one is for mass detection. We have ample amount of applications these days where people work on mass detection. This one which you see is like from a remote distance identifying the body temperature of people without actually making them pass through the thermal scanning process, right? So this is again an ML model which is identifying the temperature of people. This image that you see is analyzing the cuffing pattern, cuffing pattern of a person, and basically identifying the pattern which relates to COVID-19 infection or a normal cuffing which is not COVID-19 infection. So identifying the pattern, cuffing pattern, in order to basically know that in a public place if there is a person who is already infected. So people working on this kind of application as well. And this one which you see is like a thermal camera which is generating thermal scans of people, and through this basically identifying the temperature of each one of them. And this is all being done remotely without any manual intervention of actually going and making a person stand with that device where you measure temperature, something like that. So nothing like that. You just have a video, you have a camera, right? And the camera is doing this kind of diagnosis. And like I showed you at the start of the presentation, the ML algorithms, they need data in the form of a video, image, text, or audio. So as long as you have a camera which is capturing this image, it's an image or it may be a video which is captured by the system, and then the system has a process of converting that input as numbers, and then applying various deep learning algorithms for the required application development. Next comes AI for support and treatment. So here also, I mean, you will see some interesting examples of new floor scrubbing robots, right? So robots being used for sanitization, then UV sanitization robots being used in hospitals. Then we have this, I don't know why the video is not playing. If I can. Anyway, so basically, there in China, in Japan, there are lots of instances of robots being used for automation process to provide a automated health care facility to patients and things like that, right? So that's again an example where AI is being used heavily. Then AI for support and treatment and drug discovery. So this is an interesting slide. The slide I've basically taken from NVIDIA's one of the presentations. So you can see that structure-based drug discovery workflow where we have genomic sequencing, then this basically generates a protein sequence and then protein structure prediction. Then you have people working on protein structure, then docking and HTP screening, right? The protein ligand interaction, molecular dynamics. So a variety of these domains where people are working in terms of identification of a new vaccine or typically known as a drug discovery process. So here again, if you just look at these flags, so genomic sequencing, ML based sequence and proteomics is what is how machine learning can be used for. Then machine learned particle picking for cryo-electron microscopy, machine learned contact maps for protein structure prediction, machine learning binding energy prediction by during the docking process. So docking is a process where you have target molecules and then you have ligands, and you basically you work or you write programs of multiple ways of combining the ligands with the protein with the molecular structure so as to generate a new drug. And the quality of the generation of this new molecule or new drug is on the binding energy that is released, right? And several other property analysis as well. So that's again where softwares are written for the docking process. Then you have machine learning algorithms being used for protein ligand interaction. So a variety, all these grayish boxes that you see, they are ML based algorithms used in different process of the drug discovery process. This is, we may not discuss in detail about the model, but yes, in deep learning, deep learning as a class of machine learning algorithms is being used for the docking process in identification of the new vaccines, right? I do not have much exposure as far as this process is concerned, but of course I know the complexity of working in this problem, and the complexity is because COVID-19 is developing variety of strands, right? So there was an article saying that it keeps self-mutating, and there are some 21 different types of this virus that is existing at different places. So you make a vaccine, but what's the guarantee that the vaccine will basically work for the kind of virus structure that you have basically developed it for? So that was in totality, the areas where AI can be used or AI is being used globally to combat the challenges and issues arising for accommodating ourselves to deal with the present COVID-19 pandemic situation. And if I just sum up the three AI priorities in this COVID-19 era, it's like AI and data analytics based skill development is very, very important. And so basically, for the skill development in this domain, there are variety of things like working or learning the data analytic process, learning the fundamentals of AI in terms of machine learning algorithms, deep learning algorithms, learning Python, which is basically the base for design of majority of these algorithms, right? And then the other priority that we should try to get associated with is development of applications to support the treatment and prevention of COVID-19, right? And so applications would be like the surveillance application and many applications we just spoke of, and COVID-19 research collaboration without any geographical boundaries, like the federated learning approach for developing a mature model of identification or diagnosis of COVID-19 from chest X-ray and chest CT scans is concerned, right? So that example which I gave you, and there are of course many other research collaborations where multiple organizations are coming together, joining hands with people of varied domains to try and make a contribution to this particular domain. So what we need to focus on is applications which are recovery based, applications which are response based, which are prevention based, and which are AI based, right? In terms of, and for each one of them, I've just given some examples which we have already discussed, in one or the other way, right? So I think that was the summary of our discussion in terms of deciding upon the AI priorities in COVID-19 era. And that's all from my side.
Okay.
So if there are any questions, you can speak, you can write on the chat window, or I mean, or if Rose allows, I mean, you can also unmute yourself and you can speak up, you can make a point, or we can just have an open discussion as well.
Yeah, thank you, Priyanka. If you do have a question, please raise your hand, and I'm more than willing to open up the lines for you to do this orally. We've got Omar with a question. Please, Omar, let me know what you.
Yeah, hello.
Hello.
Hello, Omar.
Okay, my question is that my concept on AI and deep learning is a bit weak, all right? So I'll put on the question like this, that we provide the data for machine learning to analyze and give us the report, right? When it's done with the testing on that data which we have provided, does it repeatedly test on that data, or does it go somewhere else and look for some other data? Means like, do we set the parameters or the boundaries for the AI we developed, or it doesn't have a boundaries or parameters?
So, I mean, when you're working with AI algorithm, there are two phases that you work in. One is the training phase and the other one is the testing phase, right? The parameter setting and all which you have just mentioned is something which is done during the training phase, right? And then based on that you develop your weight metrics, or you develop the structure of your model. And during the test time, it is expected that your model is tested on a data which it has never seen before, right? So test data is something on which the model is not trained before.
Okay, but
does that answer your question?
Okay, just one more thing, that it's doing the testing which we have provided, right? It doesn't go outside and look for the data itself.
I didn't get your point. Go outside and look for the data, as in?
It means like it doesn't means like it's not that smart enough that it goes somewhere else and look for the data which is similar to the data which we provided.
No, I mean, you have to define how you want to test your model, right? So see, there could be two ways. One could be that you have designed a system real-time working abilities. For example, if it's like detecting an anomaly from a video camera, right? So it's not like you are feeding test data again and again to verify whether your model is working or not, because that test data is what it's basically the data that your camera is reading in real time. Okay, so and then there could be instances, for example, if we speak about the chest x-ray related application. So it's like you develop a model and then your test data is one of the chest x-ray scans. You just test the model on that, you again change the data, and likewise.
Okay, thank you very much.
So it could be a real-time data feed, and it could be a explicitly selected data as well.
Perfect. Thank you so much.
Thank you.
Thank you, Priyanka. I've got a question in the chat.
Sure.
The problem that most developers are facing is the availability of COVID data, like from X-rays, from hospitals due to ethical issues. Is there any public data set available for COVID-19?
Yes, there are data sets available for COVID-19 in terms of the chest CT scans and chest X-ray, right? But then presently we are working on a model where we are also trying to augment the chest X-ray along with the gender, age, and blood group of people, right? So this kind of data is not publicly available as per my knowledge. And we have collaborated with the hospital. Of course, there are ethical issues, so we have done a memorandum of agreement signing formally between the two organizations, and we have also agreed upon not wanting to know the name of the patient. So it's like every data is like P1, P2, P3, P4, right? That's how we are maintaining the anonymity of the data that we are working with. But yes, there are, like for chest X-ray, I mean, there are some 7-8 resources where data for COVID-19 is available, but it's just that the details of the patient are not revealed. They are like just numerically, for example, P1, P2, P3, and then X-rays corresponding to that. Or you will have two categories of data. One would be the normal chest X-ray data, and for COVID-19, you may just have data files as file 1, file 2, file 3, file 4. That's all. But still, I mean, if suppose if we need to work on severity analysis, that requires a kind of validation from the hospital. So there, yes, I mean, we need to have a direct collaboration with the hospital.
Right, thank you. Another question from the chat, Priyanka. You showed us the models to monitor crowd behavior. What do I need to learn to develop a system like that for social distancing or for crowd behavior?
I didn't get your question. Could you just repeat that?
What do I need to learn to develop a system for real-time monitoring or crowd behavior and social distancing?
Okay, so see, for social distancing, first thing that we need to learn is identification of or object detection, where the object is a person. So detecting person in a video, and then what we do is we basically need to identify or we need to define a minimum threshold between the two boxes, where one box is encapsulating the one person and the other box is like the bounding box of another person. So what is typically done is you calculate the centroid or median of both these boxes, and then you define minimum distance between that centroid. So let's say if we say the minimum distance should be x, so whenever the minimum distance between the two centroids is less than x, the color of the box will change. That's the logic which we use. And there are deep learning based object detection models like YOLO and RCNN, many others. So where you can train the model to get the bounding boxes associated with persons, and then you have to write a logic over that where you are defining the social distancing norms in terms of mentioning the minimum distance between these two centroid points.
Right.
And that is what was done in the video which I was just sharing with all of you.
Okay, any other question? Please raise your hands. Otherwise, we getting to the hour. If there are no questions, I'd like to thank Priyanka for joining us today and giving us this lecture on COVID-19 and bringing us the hope that a next pandemic might be prevented or even better managed than the one we enfriended it with last year. So thanks again all for joining this session. I hope it has been productive and worth your time. Please keep in touch with us, and hopefully till a next time. Thank you all.
Yeah, thank you all. Thank you.